Do you recognize this refraction diagram? It looks pretty standard, but there's a big mistake in it that 2/3 of students missed in the exam. I'll give you a hint. How are refraction angles supposed to be drawn? In refraction, the angles that we use in the equations are always drawn between the ray line and the normal line. But in this diagram, you can see the angles have been drawn between the ray line and the surface. So if you spot this early, you instantly protect yourself from a classic exam trap. Now on to the question. The question is asking us, out of these three statements, which ones are true? So let's look at the first two, which are pretty easy to solve straight away. Statement 1 says that the wavelength in glass is less than the wavelength in air. This is true. We know that the speed of light in glass is lower than the speed of light in air, and the frequency never changes in refraction. So how do we know that the wavelength is less? The wave speed equation is speed is wavelength times frequency. So if the frequency remains constant and we know the speed is lower, it means that the wavelength has to be less. So statement 1 is true. Now on to statement 2. It says that the refractive index of glass is twice the refractive index of air. Now you can just recall that the refractive index of air is just 1. And the question just literally tells you that the refractive index of glass is 1.51. So this statement is not true. On to statement 3. Now this is where most students will get caught. Now notice in this question, we don't have any angles. So we can't use Snell's law and we're forced to use the only remaining equation, which is the critical angle equation. So let's just write that in. Now remember, this equation is given to you in the formula sheet. Whenever it's a refraction question with air and a material, the critical angle equation can be written like this. Sine of the critical angle is equal to 1 over the refractive index of the material. We know that the refractive index of glass is 1.51. So when you put this into the equation and find the critical angle, you get 41.5 degrees. Now remember, the critical angle tells us the angle at which total internal reflection occurs. So anything above this angle, for the angle of incidence, the light will completely reflect. But in this question, we can see that the light refracts. So the fact that it refracts tells us the angle of incidence should be less than 41.5. So here's the really important part. So let's just label this to make sure we understand that the angle in here has to be less than 41.5 degrees. So the fact that this has to be less than 41.5 degrees, this angle has to be greater than 90 minus 41.5. That's how we get the missing angle. 90 minus 41.5, and that's 48.5. So this angle has to be greater than 48.5. And so this statement is true. And this is exactly why top students train themselves to spot diagram traps before the maths. If you know your physics but still make mistakes under exam pressure, then comment the word physics and I'll send you the method my students use to stay calm in the exams.